Okay then. Uh, Good afternoon, all. Today we are going to see about register, but before that we need to check about conversions, right? So we in last lecture we saw about flip-flop, right? Flip-flop as memory element, right? We can store one bit in a flip-flop. So we saw about ESR flip-flop, then JK flip-flop, then what is race around condition, then how to remove that race around condition by using master-slave arrangement, right? So that is all about flip-flop. So today we are going to see about excitation table, and that excitation table is used for conversion basically, right? Convert one flip-flop into another, and at that moment actually this excitation table are used, and after that we'll start with register, right? So first let me share my screen. Is my screen visible? Is my screen visible? Okay. So uh, first we go with excitation table, right? So before going to excitation table, we are going to check about JK flip flop, right? Excitation table of JK flip flop. So we'll see uh, what all inputs and outputs are considered in case of JK, right? So this is J, this is K, and output on this input. So if it is 0, 0, no, if J is 0, K is 0, whatever is there in Q is present over there, right? Then if 0, J is 0, then K is 1, then it resets, right? If J is 1 and K is 0, then it sets the flip flop, right? And if J is 1 and K is 1, whatever is there in memory is complemented. So this is about, a table which is used for JK. Now, first of all, we'll see, you know, characteristic table for JK flip-flop. Now, what is characteristic table is? Characteristic table shows all characteristic of JK flip-flop, right? So it is basically you call it as truth table with all its possibilities, right? So what we require in this case is we require two input basically and previous output. If we call this is a previous output as Qn here, then my next output will be Un plus 1, right? So we need to find out the previous output on previous output and input. So this is my combination for three input. So combination for three input is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. Those are those are all combinations which are based on three variable input, right? So those are totally eight inputs present over there, eight rather combinations present over there, right? So we'll identify, what is my next input. So we need to check based on inputs and previous output. So this is my uh, 0, 0th input. At that moment, no, what should be there, right? If J is 0 and K is 0, whatever is there in memory should be there, right? Qn, or you call it directly as 0, right? Then About 0, 1, it is reset, right? Reset means again 0. 1, 0 is used for setting up a flip-flop. 1, 1. In that case, what will happen? Whatever is there inside memory is complemented, right? So 0 becomes 1 in that case. Again, 0, 0, right? In that case, what will be there? Whatever is there in memory is kept as it is there, right? Then 0, 1. 0, 1 is again reset the flip-flop. 1, 0 is set is used basically to set the flip-flop. Now 1, 1, right? For 1, 1 combination, what is there? Whatever is there in memory is complemented. So 1 is there, complement of 1 is 0, right? So this is basically a characteristic table based on given input and output, right? इथपर्यंत समजलं का? इथपर्यंत समजलं का? कॅरेक्टरिस्टिक टेबल कसं आपण आयडेंटिफाय केलं, सगळे सगळे कॉम्बिनेशन, सगळ्या व्हॅल्यूज कशा काढल्या कळलं? अरे रिप्लाय टाका, कळलं नाही कळलं. ओके. So based on this input and output combinations, we find out next output, and this is about all cases, and this is referred as characteristic. Now, what is excitation table is? So from present state, right? From present state, what minimum inputs are required, which is shown in tabular form, right? Is basically referred as excitation table. So we are actually working on what inputs we require to have a current output. So we have previous output and we have next output with us, and based on those outputs we actually find inputs for those output, and that process or that table is basically referred as excitation table. So we have, this is my previous output, this is my current or next output. So we have two variables. So based on those two variables, what combinations it has? It has four combinations, right? 0, 0, 0, 1, 1, 0, and 1, 1, right? So if my previous output is 0, then my next output would be either 0 or 1, right? And if my previous output is 1, it becomes either 0 or it keeps as it is, right? 1. So this is basically a combination of previous and current output, or and based on this current output and next output, previous output, we are going to find the input combinations what we require, right? So this excitation table again is going to see or going to form based on characteristic table, right? So what is my current or previous output, which is, or you say, what is my current output? 0. And what should be the next output is 0, right? So we need to find the all possible, sorry, okay, the all possible combinations which are there in characteristic table, right? So this is my current output, and this is my next output, which is 0. This is again a current output, this is my next output, which is 0. So this is my combination, right, wherein two outputs are there which are 0, 0, right? So all others are different combinations, right? So Based on this, we need to find inputs, right? So those are my input. In that case, J is always 0, right? K could be either 0 or 1, right? In that case, J is always 0. K could be either 0 or 1. So basically, this type of current and next output is depends on J's zeroth value, right? If J is 0, then your current output is converted from 0 to 0 as well. That means reset state, right? And K would be either 0 or 1. That means we don't care about the K's input, right? So this is my first row in excitation table. Now next is my current output is 0 and my next output would be 1. So that combination we need to find, right? So here it is 0 is my current output, 1 is next output. 0 is again current output, next is 0th output. Sorry, 1, right? So this combination. Then again we need to check another combination. Basically, no, those two are only combinations available. So we need to check on this input condition, right? In this case, again, J is always 1 and K could be either 1 or 0, right? That means if J is always 1, then only it sets the flip flop. We don't care about kth input, right? Now, next is my current input is 1 and my next output is 0. Now, my current input, current output is 1 and next output is 0. Here again, my current input is 1 and next output is uh, 0, right? So, those combinations, right? In that case, again, K is always 1 and J could be either 0 or 1. That means don't care, right? So if we have K equal to 1, in that case, it resets the flip flop, right? Then next row. What is my current input is 1. What would be my next output is, what is my current output is 1. What would be my next output is again 1, right? So what all combinations are there as 1, 1? Those two combinations, right? Those two combinations are input or current output is 1 and next output is always 1, right? So in that case also my K is 0 always and J would be either 0 or 1, right? So in that case, J is my don't care and K is always 0, right? So this is how you convert your table into a characteristic table into excitation table. So we have a true table with us, characteristic table with us, and excitation table with us on screen. Right? इथपर्यंत समजलं का एक्सायटेशन टेबल काय आहे? त्याच्यात काही इश्यू आहेत का? नाही समजलं असं वगैरे? कुणाला काही इश्यू आहेत का? Okay. So next is resistors, right? So basically, flip flop is one bit memory cell. So you can store one bit there inside flip flop, right? What if I want to store multiple bits in a memory, right? So we need to arrange flip flops in such a way that we can store those multiple bits, right? So if we have such kind of group of flip flop, then this is referred as register, right? If you have a group of flip flop there with you to store multiple bits, then that group of flip flop is referred as register, right? So group of flip flop is register. So if I want to store 3 bits, then how many flip flop is required? 3 flip flop is required, right? One bit in one flip flop, right? So 3 flip flops are required. So to create a register, we require 3 flip flop, right? We can store 3 bit in a register, but for that reason, we require the 3 flip flops. Say suppose this is my flip flop and this is the input, or you can say a data input. Then this is output. Again, those are D2, D1, D0, Q0, Q1, and Q2 is flip flop arrangement. Then how to assign a clock? You can assign a same clock to each and every flip flop, right? So this is flip flop 0, flip flop 1, flip flop 2, right? So we can have this kind of arrangement. You also connect preset, and this is my preset. Again, this is clear, and this is my clock, right? So you can store multiple bits in register. So how many bits, if you require to store n number of bits in a register, then n number of flip flops is required to store n number of bits into register. So if you are going to store 3 bits in a flip flop, you require 3 flip flops. You want to store 4 bits in that register, then you require 4 flip flops for that. Sorry, for that register, right? So this is basically about register, and we are using D type flip flop to store values, right, inside register, right? So if we want to have a register, we are actually using D type of flip flop to store the values, right? Then how we can store these values inside register? There are so many forms available. You can store that data serially or parallelly. So serial form is there to store data, and parallel form is also there. You store data serially, that means one bit at a time, right? And you store that data or get that data out from those register, that means all bit simultaneously, right? That means this is your parallel form. In serial form, one bit at a time you can store or you can retrieve from the register, and in parallel form all bits are simultaneously stored inside the register or simultaneously gets out from the register, right? So serial arrangement is also called as temporal code, right? Temporal code, that means time arrangement. This is simply called as time arrangement, whereas parallel form is referred as spatial code, whereas in parallel form you can have your data at a time, but in serial form this is basically a temporal arrangement or a time arrangement, right? And that is why it is called as temporal code. So how many ways are uh, available there? If suppose we have four flip-flop over there. So this is the third number, second, first, and zero. So four flip-flops are there. In that case, you can serially input data as well as you can have serially get out that data, right? This is one way, right? So this is called serial in and serial out, right? Serial in, serial out. You also can have serial in and parallel out, right? There are different applications for this serial and parallel arrangement, but you can check out just the difference in between, right? So you can have serially in, parallelly out, right? This is also one arrangement. Again, you can have parallelly store the data and serially gets out that data, right? So parallel in, serial out arrangement is also there. Again, you can have parallelly in and parallelly out, right? This type of arrangement is also there, right? So this is actually, or this classification is based on data in and out, right? That means how you are going to enter your data in flip flop or register, and how you can retrieve that data from the register, right? So this arrangement is basically depends on how you enter the data and how you retrieve your data. This uh, this difference, or you can say, you also can classify the what we say register based on its application as, right. So there are two type of registers available, which are called chip register and one is storage register, right? So it is based on application. So this type of classification is based on application, and this classification is based on how you enter your data and how you retrieve your data. So shift register means you simply shift your data from number of flip-flops available with you, right? So this is what is a shift register. And storage register means you can have only store the data for a moment and you get out that data from the register, right? So which one is storage register? From this is parallel in, parallel out is only a storage register available. All other, that means serial in, serial out, serial in, parallel out, and parallel in, serial out, all are shift registers available with us, right? So those all are shift registers. And parallel in and parallel out are only the storage register. So this is about, you can say classification available with us. Till now, is it clear for you about register? Okay, tell me what is register? कळलं काय आतापर्यंत जे काय झालं? Okay, tell me what is register? Put it in chat. What is register? Yes, it is an arrangement wherein we group a flip-flop to store multiple bits in it, right? So register is basically group of flip-flop wherein we use that group of flip-flop to store the multiple bits, right? There are classifications available in this. We can store data in serial way, we can store data in parallel way. Classification of register is based on data, how you enter your data and how you retrieve your data. Based on that, there are there are the four types available. That is serial in, serial out, serial in parallel out, parallel in serial out, and parallel in parallel out. And based on applications, we have two type of registers. One is shift register, one is storage register. Shift register basically wherein data is shifted from those flip-flops available in register. That means data is shifted from one flip-flop to another, right? So basically, this is called type of flip-flops available with us, right? Now, first is serial in, serial out. If suppose I have four flip-flops available or four bits available with me, in that case, how it is if I consider this is my flip-flop 3, 2, 1, 0. So this is my D3. Q3 basically connected as D2. Q2 connected as D1. Q1 connected as D0. And from here it is Q0. So data is entered from here and we get out our data from here. So this is serial out, right? We can assign clock pulse to each and every flip-flop like this, right? So this is what is my, sorry, this is what is a serial in, serial out. So data is serially in this way, and we get out data in this way, right? So how actually this works? If suppose this those are my outputs, sorry, Q1 and Q0. Then, if I want to store 1111 inside those flip-flops, then how actually it is entered? Initially, all those are 0000, right? When we assign first clock pulse to it, then this 1 is assigned to this flip-flop, right? So 1 is fast, all others are 0. Again, next bit. In next clock pulse, this 1 is there, and again, Q3's 1 is assigned to D2, and so on. Then for next clock pulse, all others are 0, and this one Q0 is 0. Then fourth clock pulse, all ones are assigned to each and every flip-flop in this case, right? Now, what if I want to get out all those data from this output, right? So in that case, what will happen? We require next four clock pulses. In that case, this is zero and one is out from here. At next clock pulse, two ones are out. At next clock pulse, three ones are out. And at fourth clock pulse, all ones are out from serial output, right? So we require four extra clock pulses to get that data out from those what we say flip-flops. That means how many number of data bits are there, that many clock pulses we require to get that data out from register. This is basically a drawback. But where actually this type of registers are used in case of long distance transmission or long distance data transmission, where this type of arrangements are used to send and receive the data, right? So in case of long distance transmission, serial in, serial out kind of data uh, retrieving and entering process is used, right? So this is basically a serial in, serial out type of resistor. Now, this is about, arrangement called serial in parallel, serial in, serial out. Now, serial in parallel out. In this type of arrangement, again, flip-flops, the data entered in this case is serial arrangement, right? So this is my D3, sorry, this is my Q3, this is my D2, Q2, D1, Q1, D0, Q0, right? This is how data is entered. Clock pulse is passed like this, and then arrangement of data result that gets out is this is my Q3, this is Q2, this is Q1, and Q0, right? So you can have data out in this fashion in case of serial and serial out. That means this arrangement is like bits are entered in this fashion, right? Bits are entered this in this fashion and gets out like this, right? So this is type of arrangement wherein we have this type of arrangement for serial in parallel out. So we require only four clock pulses to enter the data, and not a single clock pulse is required to get that data out, because data is already there on output line and we connect all those output lines at data out, right? So we are not required mm, any clock pulse to get out that data from what we say from this thing register, right? So this arrangement is basically referred as serial in parallel. Now we'll check, parallel in, parallel out type. So data is, so those are bits D2, D1, D2, D1, D0. Data is parallelly in from this and gets out from this flip-flop. So data in is parallelly there and data out, right? So we can have this is referred as storage register, right? This is referred as storage register, or you call it as buffer register, wherein data is passed directly to each and every flip-flop and gets out from those flip-flop on a single clock pulse, right? So you just set a flip-flop and get that data out from your flip-flop, right? And one more is called serial in, parallel out, wherein we require special type of arrangement and to load the data and to get that data out, right? But before that, why shift registers are used, or why shifting is important in case of uh, this flip-flop arrangement that we'll see, right? Why shifting is important, right? So consider this number. Basically, this is binary 3, right? So just shift those by one bit to left, right? So we'll shift those bits to left by one bit, right? So what will happen here? This bit goes here, this bit goes here, this bit goes here, right? So it is one comes here, again one comes here, zero goes, right? Find out what is this. This is basically a binary code for 6, right? So just by shifting bit to left, we can multiply whatever we have in that by 2, right? So just by shifting those bits, we can achieve multiplication operation, right? Again, this is the same case for shifting right. If we shift this bit to there, this bit to here, and this to here, that means 1, 1, 0. That means again it becomes C, right? So this is basically a division. So if we shift bits to right, will achieve division operation, right? So that is why shifting is important. If you shift your bits left, then you will achieve multiply operation. And if you shift those bits to right, then you will achieve division operation. No? Right? So this is basically called shifting. And why shifting is used? Because we achieve something there in this case, right? So now next is parallel in, serial out. So this is my 4-bit flip-flop arrangement. This is FF0, FF2. You can consider any flip-flop with any number, right? But what you need to do is to pass one there, right? So parallel in, that means data could be entered parallelly, right? So this is my bit 0. This is my D0, U0, right? And it could be go out serially. That means data connection should be in this way also and in this way also. So what we need to do for this is we are using special type of arrangement of gates here. We are using this type of arrangement of gates wherein we can have data. If it is 1, then shifting the data. If it is 0, then it actually is loading the data, right? So for loading, this is my B1 and this is connected here. And for shifting, we need to connect to this line. Again, same arrangement here. This is OR gate, right? So data is shifting with this and data is loading with this, right? Again, this is connected to here. Data is basically shifting with this. Data is loading with this. Again is connected to here. And this is my Q3, P3, Q2, D2, Q1, D1. And clock pulse is assigned directly. Now, what will happen in load mode? If this is 0, then this line is, if load is 0, then this line is active. Then whatever is connected to this, right, or data which is there, if suppose 1 1 1 1 is data which are there on those input lines, should directly be passed to those flip-flops. What if I want to shift? Then this could be 1, right? If the shift is 1, then that means it becomes rather, if it is 0, or if it is 1, then this is active, right? In that case, whatever, or this becomes all 1. So whatever is there should be activated, and here it is OR gates are present. So any any input from those two AND gates should be entered and taken as input. So data is basically shifting here to those flip-flops, right? Data basically shifting from flip-flop 0 to 1 and again 1 to 2 and 2 to 3. So this is how you can have the arrangement of parallel in serial out resistor, right? So what you need to do is you need to try bidirectional resistor as your homework there, right? So bidirectional resistor तुम्ही homework साठी यूज करायचा आहे. ही जी अरेंजमेंट आहे that arrangement is called parallel in serial out data, right? Parallelly data in होतो फ्लिप फ्लॉप मध्ये, डेटा स्टोअर होतो फ्लिप फ्लॉप मध्ये आणि सिरियली डेटा आउट होतो, राईट? इथं झिरो असेल त्यावेळेस लोड हा वन होतो, झिरोचा इन्व्हर्जन वन, आणि हा वन असेल बेसिकली त्यावेळेस परत हा इन्व्हर्ट होऊन हा झिरो होतो. हा झिरो झाला की हे इनऍक्टिव्ह असतं, इनऍक्टिव्ह, आणि ही लाईन ऍक्टिव्ह होते, राईट? आणि याच्यावर जे कर म्हणजे वन 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 या लाईनला येतं आणि त्याच्यावर जर जे काही बिट्स आहेत ते बिट्स पास होतात, राईट, टू अदर फ्लिप फ्लॉप. समजलं का इथपर्यंत? समजलं का? काही प्रॉब्लेम आहेत का? ओके, चॅट मध्ये टाका, समजलंय का? टोटल 4 टाईपचे रजिस्टर झाले. विथ मी, समजले का?